everyone, we're going to find the inverse of this function f. We're going to check to make sure we did it right by composing both f with f inverse, find the domain and range of each, and graph both of them. So the first thing we do is we change this to y and switch the x and the y and solve for y. So I'm going to subtract the 2 and divide by 4. So that's your inverse. And for graphing purposes, this is like saying x over 4 minus 1/2. Okay, so let's check that we did it right. And to do that, we're going to compose f with f inverse. And if we should get x. So I'm going to write down f and leave a blank for the x and input x minus 2 over 4. What happens is the 4's cancel and you have x minus 2 plus 2, which equals x. We also have to go the other way. So I'm going to write down f inverse, but everywhere there's an x, I'm going to leave a blank, and I'm going to input 4x plus 2. So the numerator ends up being 4x over 4, which equals x. Both of these are linear, like the previous video, part 1. So the domain and range for both the f and f inverse are both all real numbers. We're going to get into harder ones where we have to have more restriction. So we're going to graph these and take the graph paper and go ahead and draw the line y equals x in the middle here. So this is y equals x. And I'm going to graph 4x plus 2. Means the y-intercept is 2. You go up 4 over 1 and down 4 over 1. So we're going to try to connect that. That's your function. And our other function was y equals 1/4 x minus 1/2. So this one's going to be a little harder. You go to negative 1/2. Let's do a different color. And we're going to go up 1 over 4. I'm going to go ahead and go down 1 over 4. Okay, so basically I'm writing here. I graph this. And this should have connected right in there. And they're inverses of each other, and there's your graphs. Okay, we're going to do one that's similar. So we go back to that paper, and we're going to have f of x equals 1 minus 3x. And then we change this to y. Switch the x and the y. And solve for y. I'm going to move the 3y over here. And the negative x plus 1. Divide everything by 3. Now so this is your inverse. Now we got to check f composed with f inverse. I'm going to write down my f first. Leave a blank for the x and input my inverse, which is negative 1/3 x plus 1/3. When you distribute here, you're going to get 1 plus x minus 1, and that's going to be equal to x. You're just distributing here. And so that's true. And now let's do the other way. F inverse composed with f of x. So I'm going to write him down, leave a blank for the x, and input f of x. I distribute, and I get negative 1/3 plus x, and this is going to be plus 1/3. So this cancels, and we get x. Good. So we did it right. I do want to rewrite this one for our graphs. That's going to be, so that's our f. I'm going to just rewrite it as negative 3x plus 1. I'm just used to seeing it that way. All right, now let's graph it. So we have the coordinate grid. I'm going to go ahead and graph y equals x here as best I can. So this is y equals x. And I have negative 3x plus 1. So our y-intercept is at 1, but we're going up 1, 2, 3 to the left, sorry. And down 3 to the right. So there's your original f function. All right, that's f. And then our inverse was negative 1/3 plus 1/3. Okay, so we're going to start at 1/3, which is right about here. And then we're going to go up 1 over 3. No, over 3 this way. 1, 2, 3. And down 1 over 3 this way. 1, 2, 3. That's how I graph it. I don't know. You graph it the best way you know. And then we kind of connect these. And this is F inverse. And there's your reflection over the y equals x. Okay, thank you. Have a nice day. Bye-bye.